Right, this is May 2018, Combined Science Trilogy, Paper 1. This one got wet in the bag on the way home. Hopefully yours isn't. Foundation tier. Question 1, Part 1. There are many different energy resources. Which two energy resources are renewable? Tick two boxes. Biofuel, coal, gas, geothermal, or nuclear fuel. The correct answer are biofuel and geothermal. Some non-renewable energy resources are more reliable than others. Which statement correctly describes a reliable source resource? It does not burn fuel. It is predictable. It will never run out. It is cheap to use. One box. It is predictable. Figure 1 shows a wind farm. The total power output of the wind farm is 19.6 megawatts. All of the wind turbines have the same power output. What is the power output of one wind turbine? 1, 2, 3, 4, 5, 6, 7. The correct answer is 19.6 divided by 7, 2.8 megawatts. Give two reasons why people might not like having wind turbines near their homes. Something like noise pollution, they don't look very good, visual pollution, they're a danger to birds, they could lower their house prices. Figure 2 shows the electricity generated by different energy resources in the UK. The total amount of electricity generated was the same in 2014 and in 2015. There are changes in the amount of different energy resources used between 2014 and 2015. Explain the environmental impacts of the change. There is more nuclear, so therefore there is less CO2 produced, emitted. There is less coal, so there are fewer greenhouse gases. There are more renewables. There is less acid rain or less global warming. Power source provides a current of 1.86 amps at a potential difference of 3.90 volts. Calculate the power of the power source. Use the equation power equals potential difference times current. P equals IV. Choose the correct unit from the box. I is 1.86, V is 3.90. 1.86 times 3.90 equals 7.254. To three decimal places, 7.25 watts. The power is 7.25, the unit is watts. The student needs a new power source. Figure 4 shows three different sized power sources. High capacity, large, compact. The power source compact, number of charges 1, mass in grams 100. Power source large, number of charges 5, mass in grams 200. High capacity, number of charges 10, mass in grams 600. The student chose the large power source. Suggest why the student chose the large power source. We can see here that you get 5 times more charges, but only twice the mass of the compact. 5 times more charges, but only 2 times the mass. Compared to the high, high has twice as many charges, but it's 3 times larger, or 10 times larger than this compact. 10 times as many charges. Figure 3 shows a mobile phone being recharged by a portable power source. Why does the battery in the phone need recharging? Tick one box. The store of chemical energy in the battery has reduced. The store of thermal energy in the battery has reduced. The store of kinetic energy in the battery has reduced. The store of gravitational energy in the battery has reduced. Correct answer is 1. The store of chemical energy in the battery. Figure 5 shows a girl skateboarding on a semicircular ramp. The ramp is 4 meters tall. The girl has a mass of 50 kilograms. Calculate the gravitational potential energy, GPE, of the girl at the top of the ramp. Use the equation GPE equals mass times gravitational field strength times height, mgh. Gravitational field strength, 9.8 newtons per kilogram. The mass is 50 kilograms. The height is 4.0 meters. G is 9.8. 50 times 9.8 times 4 gives us a gravitational potential energy of 1,960 joules. The girl has a speed of 7 meters per second at the bottom of the ramp. Calculate the kinetic energy of the girl at the bottom of the ramp. Use the equation kinetic energy equals half mass times speed squared. Mass is 50, speed is 7, so half times 50 times 7 squared is equal to 1,225. Not all of the GPE has been transferred to kinetic energy. Which two statements explain why? Tick two boxes. Some energy is wasted. The mass of the girl is too low. The ramp is not high enough. The GPU of the girl is not 0. The correct answer, the speed of the girl is too great. The correct answer is some energy is wasted and the GPU of the girl is not 0. Explain how lubricating the wheels of the skateboard can increase the speed of the girl. Use your ideas about energy in your explanation. It reduces the amount of friction, so less energy is wasted, so there is more kinetic energy. Some ceiling lights in a home are connected to the mains by a 2-core cable. Figure 6 shows a ceiling light, insulation, and a copper wire. Suggest why some ceiling lights do not have an earth wire. You only need an earth wire if the component is made of metal. There is no chance of an electric shock, as it is made from plastic. Write down the equation that links charge, flow, current, and time. Q equals IT. Charge is current times time. There is a current of 2.95 amps in one copper wire for 60 seconds. Calculate the charge flow through the wire. I is 2.95. 2.95 times 60 equals 177 coulombs. Figure 7 shows a current potential graph for a piece of copper wire. Draw another line for a wire with a different resistance. I have just drawn another straight line going through the origin, but at a slightly different gradient. Some fuses have a thin piece of copper that melts if the current is too large. Draw the circuit symbol for a fuse. Describe how the movement of copper particles in the wire changes when copper melts. Particles vibrate about a fixed position in a solid. When they're heated, they melt, they become free to move more. Old copper wires are melted when they are recycled. Calculate the energy needed to melt 500 kilograms of copper at its melting point. The specific latent heat of fusion of copper is 200 kilojoules per kilogram. The equation is E equals ml. Energy is mass times specific latent heat. So 500 multiplied by 200,000 is 1 times 10 to the 8 joules. Radioactive nuclei can emit alpha, beta, or gamma radiation. Which type of radiation is the most penetrating? Take one box. Alpha, beta, or gamma? The answer is gamma. Which type of radiation is the most ionizing? Alpha, beta, or gamma? Take one box. The answer is alpha. Which type of radiation has the longest range in air? Take one box. Alpha, beta, or gamma? The answer is gamma. When radioactive isotopes in the Earth's crust decay, they release energy. This decay causes the heating of the rocks in the crust. Figure 8 shows the decay of uranium-238 into thorium-234. 238, 92 uranium goes to 234, 90 thorium plus 42 helium. Complete table 2 to show the number of neutrons and protons in the nuclei. For uranium-238, we have 146. To work out the number of protons, we do 238 minus 146 is 92. Thorium-234, 234 minus 90 gives us 144 neutrons. Geothermal power stations pump water through heated rocks. The temperature of the water increases from 20 degrees to its boiling point of 100 degrees. Calculate the change in thermal energy when the mass of the water heated is 150 when the mass of water heated is 150 kilograms. Specific heat capacity 4,200 joules per kilogram per degree Celsius. The change in temperature is 80 degrees, 20 to 100. The mass is 150. Specific heat capacity of water is 4,200. 4,200 times 150 times 80 equals 50,400,000 joules. Figure 9 shows two models of the atom, the plum pudding model and the nuclear model. Write the labels on figure 9. Choose the answers from the box. This is the electron, this is the atom, this is the nucleus, and this is the orbit. Explain why the total positive charge in every atom of an element is always the same. Protons are positive. Specific elements always contain the same number of protons, therefore, the same number of charges in the nucleus. Results from the alpha particle scattering experiment led to the nuclear model. Alpha particles were fired at a thin film of gold at a speed of 7% the speed of light. Determine the speed of the alpha particles. Speed of light is 300 million meters per second. You do the speed of light multiplied by 7 divided by 100 equals 21 million meters per second. Figure 10 shows two atoms represented as solid spheres. A hydrogen atom has a radius of 2 times 10, 2.5 times 10 to the minus 11. Determine the radius of the magnesium atom. You have to measure the actual diameter of this on the page. It's 12 millimeters. So if you halve it, the radius is 6 millimeters. You do the same. The radius of this is 76 millimeters. Halving it, sorry, the diameter is 76. Halving it, you get 38. If the size of this is 2.5 times 10 to the minus 11 divided by 6 millimeters, because that's how long it is, and then you multiply it by the 38 for the millimeters of this one, gives us 1.58 times 10 to the minus 10 meters. Student wanted to determine the density of an irregular shaped object, shown in figure 11. Plan an experiment that would allow the student to determine the density of the object. You use a balance to determine the mass. You fill a Eureka can with water. Allow the water to drain from the spout. You gently place the object in the Eureka can and catch the water from the spout in a measuring cylinder. You know how I use for volume and mass. Use a cylinder to get the volume of water displaced, and the equation is density is equal to mass divided by volume. Another student did a similar experiment. He determined the density of 5 common plastic materials. Acrylic is 1200, nylon is 1000, polyester 1380, polystyrene 1040, and PVC 1100. Figure 12 shows the results plotted on a bar chart, and you just had to fill in the missing details. It's worth noting, um, each, to fit it all in, each of these little squares is 50, so two of these squares is 100, 100, 200, 300, 400, 500. So your graph should look something like that. Excuse me. The student is given a piece of different plastic material. The student determined the density of the material 3 times. Table 4 shows the results. Determine the uncertainty of the student's results. To do the uncertainty, you need the range divided by 2. The largest number is 1120, the smallest is 960. So 1120 minus 960 divided by 2 gives you uncertainty of 80 kilograms per meter cubed.